Welcome to Lesson 103. Today we're going to be working on comparing fractions to the whole number 1 and to 1/2. Now, if we think about fractions, one of the most common things that comes to mind is that when we think about fractions, we eat fractions. We cut pizza into slices. We cut our sandwiches in half or into fourths, and we cut open our oranges and peel them into slices. So when we think about fractions, fractions aren't just a random math concept, but they're also a real life thing. Now, if we look at this hexagon and we ask what fraction or part of this hexagon is red, you might say all of it. And technically you're right, but that isn't a fraction. 6 pieces out of the 6 pieces are red, so that's the fraction 6 over 6. That means it's the whole hexagon, so it's one hexagon. So 6 over 6 is the same as 1. 6 over 6 is 1, which is like a magic 1. Here are some more. 7 over 7, 15 over 15, 2 over 2, 1,234 over 1,234. Whenever the number in the top of your fraction is the same as the number in the bottom of your fraction, it's always going to equal 1. So, it's Darnell's birthday, and his mother bought him a birthday cake to bring to his after-school class for him to share with his friends. The cake was cut into 6 equal slices. If Darnell and his friends ate 3 of the 6 slices, what fraction of the cake is left over? So if I look at our cake and it's been cut into 6 slices, we can say that we're going to take away 3 of those slices because 3 of them have been eaten. So here's one that's been eaten, here's another one that's been eaten, and a third that's been eaten. Therefore, our fraction is 3 over 6. Now, if we look at this pizza, it's been cut on this side into 6 pieces, and on this side into 2 pieces. On this side, 1/2 of the pizza is gone, and on this side, 3/6 of the pizza is gone. But if you notice, it's actually the same exact amount on both sides. The first one says 1/2 and the second one says 3/6, but the same amount is gone on both circles. Therefore, 1/2 is the same as 3/6. 1/2 can be one part of 2, so we can write 1/2. But we could also say 2/4. 1, 2 is 2/4. We could also say 4/8, so all 4 of these over here are technically all equal to 1/2. So here we have 1/2 of the circle colored blue. Here we have 2/4, but again, it's just 1/2. And here we have 4/8, which is again 1/2. Therefore, there are many different ways that we can say 1/2. If we think about the number of people that we normally have in our 4th grade classroom, students and Miss Ferry, we have 12, which means half of those would be 6. 6/12 is really the same as saying 1/2. Now, to figure out how we have 1/2, we can see that our numerator is always multiplied by 2 to get the denominator when we're seeing if it's equal to 1/2. So we do 1 times 2 is 2, 5 times 2 is 10, so 5/10 is 1/2, and 22 times 2 is 44, which means it's also equal to 1/2. The denominator of 1/2 fractions are always double the numerator. We can also go in reverse. We can divide the bottom number by 2 and get half of it on the top. And that means that they are all equal to 1/2. 10 divided by 2 is 5, and 44 divided by 2 is 22. Therefore, the denominator is always double the numerator, or, same thing, the numerator is always half of the denominator. So, Mrs. Daniel cut a pizza into 8 slices. If we want to write a fraction that is equal to 1/2, but has a denominator of 8 because the pizza was cut into 8 slices, we need to figure out how to get from 1/2 to something over 8. Now, if we use our trick that we just learned up here, we know that we can divide the denominator by 2 to find the numerator. So if I do 8 divided by 2, I know that 8 divided by 2 is 4. Therefore, 1/2 is the same as 4/8. Miss Fairy bought a package of Oreos, and she counted that there were 10 Oreos in one sleeve of the container. Her brother ate half of those. If we want to write that fraction as 1/2 out of 10, we would write 10 in our denominator because that's how many Oreos we have. And if her brother ate half of them, we do 10 divided by 2. And 10 divided by 2 is 5. Therefore, 1/2 is the same as 5/10. Now, when we're comparing fractions to 1/2, we have to see if the fraction is bigger, smaller, or less than 1/2. So let's look at this problem. My brother ate 5 of the 12 donuts. Did he eat more than, less than, or exactly 1/2? So the first thing we should do is we should write down our fraction 5/12 because he ate 5 out of 12 of the donuts. Now, I'm trying to compare this to 1/2. So I'm going to give and keep my denominator as 12, and to find out what my numerator is to make it equal to 1/2, I divide 12 divided by 2, and 12 divided by 2 is 6. Now I want to compare the fractions. 5/12 is less than 6/12, which means that he ate less than 1/2 of the donuts. The girls ate 23 of the 30 bagels. Did the girls eat more than, less than, or exactly 1/2 of the bagels? Well, again, we are trying to figure out what 1/2 is of 30. So we need our denominator to stay as 30. We're going to divide by 2, and 30 divided by 2, I know, is 15. Therefore, we are now going to compare 23/30 to 15/30. And we know that 23 is bigger than 15. Therefore, the girls ate more than 1/2 of the bagels. If the students ate 3 of the 10 Oreos, did they eat more than, less than, or exactly 1/2? Well, we have 3/10 of the Oreos have been eaten. I know that my denominator is 10, and half of 10 is 5. So my 1/2 fraction is 5/10. 3/10 is less than 5/10. Therefore, the girls ate less than half of the Oreos. Now, when we're trying to figure out which fraction is greater than, equal to, or less than 1/2, we need to compare those fractions to 1/2. So, first of all, if we're looking for the fraction that equals 1/2, we're going to divide the bottom number by the top, divide the bottom number by 2, or we could even multiply the top number by 2. So 5 times 2 is 10, which is not in my denominator, so that's not equal to 1/2. 6 times 2 is 12. So I know that the fraction that's equal to 1/2 is 6/12. Now I have two fractions left. Which is less than 1/2? Now, to figure out which one is less than 1/2, the first thing I need to do is figure out what is 1/2 of these numbers. Now, 5 times 2 is 10. That number is bigger than the number that I have on the bottom of my fraction. In this one, 3 times 2 is 6, and 6 is smaller than 7. That means that 3/7 is smaller than 1/2 because the denominator was less than 1/2. And 5/9 is greater than 1/2 because the 10 when we multiplied 5 times 2 is greater than the denominator. Now we can use knowing how compared to 1/2 these fractions are to help us know how we can round. When we're trying to round a number to the nearest whole number using fractions, we want to figure out, is the fraction part bigger than 1/2 or less than 1/2? So what I can do is I can again multiply 7 times 2. When I multiply 7 times 2, I get 14. 14 is bigger than 10. That means that I should round my number up to 7. I can also use a number line. Here I have 6, 6 and a half, 6 and 7 tenths is in between 6 and a half and 7, which means I'm going to round up to 7. If I look at this fraction, I have 3 and 5/8. I'm trying to round it to the nearest whole number. If we do 5 times 2, we get 10. 10 is bigger than 8. Therefore, we need to round up, so we should round up to 4. We also know that 3 and 4/8 is the same as 1/2, and 3 and 5/8 is bigger than 3 and 4/8. That's another way to check if we should round up or down. Here's another one, 8 and 3/7. First thing we do is multiply 3 times 2, and we get 6. 6 is less than 7. That means that 3/7 is less than 1/2, which means that we have to keep the whole number the same and round back to 8. Finally, this problem says estimate the perimeter and area of the rectangle below. Remember that our key word here is estimate. That means that we should round first and then do what the problem asks us to do, which is we're going to find the perimeter and the area. So let's look at our first fraction, 7 and 7/8. If I multiply 7 times 2, I get 14. I know that 14 is bigger than 8. That means that instead of 7 and 7/8, I'm going to round up to 8. Here, I have 4 and 1/4. If I do 1 times 2, I get 2, and that's less than 4. That means that I have to stay the same at 4. Now I'm going to find my perimeter and area. Now remember, the perimeter of a rectangle means that we add up all the sides. Now right now I only have 2 labeled. So what I can do is I know that in rectangles, opposite sides are equal. So I can label that one as an 8 and this one as a 4. And when I add all of these up, 8 plus 4 is 12, plus 8 is 20, plus 4 is 24. Therefore, my perimeter is 24 inches. To find my area, I know that I multiply 2 touching sides. So I'm going to multiply 8 times 4. And when I multiply 8 times 4, I know that 8 times 4 is 32. And I also know that for area, I always give my label a squared sign. So my area is 32 inches squared.